The scale of that is, I think, bigger than most people realize. It's a large task to change the entire global atmosphere. And of course we've already done it because we're changing the composition of the atmosphere. But at the same point, I think there are enough places where there can be surprises that you poke the atmosphere in one way to get a response, and it responds the way you hope, but something else happens as well. And so personally, I don't think an engineering solution is a particularly appealing one, because you're opening yourself up to a lot of potential unknown consequences, and I just think you morally that's a dangerous thing to do.
I talked to this IPCC author, this guy Andreas Fischlein, and he was saying that he thought Crutzen was proposing it as just the absolute desperation situation.
Yeah, and I mean the problem is that carbon dioxide stays in the atmosphere a long time. We've already bought into some level of climate change as a result of the changed composition of the atmosphere, and we're not moving very quickly to reduce the amount of carbon dioxide that we're emitting, and so we're not only bought into the amount of climate change that we're getting from the amount of carbon dioxide that's in the atmosphere, but we're also accepting some larger change with the increases that are continuing to happen. So I'm not quite sure how we'll respond as a society to this.
Andreas said if humanity deals with it, it'll be the greatest cultural achievement in the world, which is pretty. I mean, it would be great.
Yes. No, I think it would be, and I think unfortunately the reality of it is that the wealthy nations will be better equipped to deal with it because they can modify their infrastructure to deal with hotter summers or longer lasting droughts or rising sea levels, and poorer nations will bear the brunt of climate change. And of course they're the ones that are least responsible for it because they're the ones that have contributed the least to the carbon dioxide load in the atmosphere at this point.
Right.
So there are a lot of...
It's a large ethical question.
It is.
Yeah.
So...
Well, let me switch gears here and then talk to you about, ask you about the human weather observers. I understand that you have, and I guess this is true, that you've gone and done storm chasing, and so that seems to be kind of putting yourself at risk a little bit. Why would you do it when you could look at a model or a satellite picture? Why would you take that kind of chance? What is it about being physically in the presence of weather?
I mean, I've been storm chasing since I was a graduate student. I actually took a storm chasing class at the University of Wisconsin.
Oh wow, I didn't know they had that. That's cool.
And I think a lot of people that study the weather and work with the weather do it because they've had an interest their whole life. Everyone experiences the weather. Everyone sort of knows something about the weather. And for some people, seeing the weather and experiencing the weather is something that appeals to us. As a scientist, I wanted to be an atmospheric scientist so I could not only experience the weather but understand why it was happening. When I go outside and we're getting strong winds or really cold temperatures, it's appealing to me to be able to think about what has gone on to give this state of the atmosphere.
Does it help you to think about it, to actually be in it?
Yes.
Oh,
without
really?
a doubt. I think experiencing the weather that you're trying to study provides you with sort of you're more fully immersed in what's happening, and it provides you with a lot of clues and a lot of bits to think about that you miss from just having a weather observation that tells you the temperature is this and the wind speed is this. And if you're standing outside and you feel the gustiness of the wind, or you see the way the clouds are moving across the sky, they're intangible things that are providing you clues to what may be going on. And so the work that I do is mostly computer modeling, and as computer modelers we never need to go outside, we never need to be away from our computers, and I work hard to make sure that all of my students get into the field and that they go to the places where they're trying to run their computer models and to simulate, because being on the ground and seeing what a place is like and seeing what the weather is like there gives you an intangible sense of the location, and it improves your interpretation and your understanding of what your computer model is telling you or what the weather data that you're seeing is telling you. So I think it's an important thing to experience that.
Can you give me maybe an example? Maybe this is too hard. I don't know. An example of how you experience something in the real world in weather, and then how you went back to the computer and like maybe something specific.
I suppose. I mean, one of the things that I get out of being in the field, that's sort of a direct benefit to me as a computer modeler, particularly with the weather station project, is that I'll go out into the field to these weather station locations, and seeing where that weather station is, you sort of get a sense of what those measurements mean. So there's a weather station up in Terra Nova Bay. It sits up on a rocky island, and it's the features around there are at a smaller scale than our models would resolve. And so in seeing that, I know that my computer simulations will never fully capture what is being observed there, because I'm not resolving all of the details of the small rocky island and the position of that weather station relative to the geography of the area. And so I think it gives you that sense that you sort of have a sense of how much you expect what you model to actually match what's being observed, because what you're modeling is something that's different than what's being observed in reality. So.
Oh, that's great. Thank you. That's like really gets down to the crux of what I've been trying to do with going to these stations.
Yep.
It's funny because you don't, like you're saying, it's this intangible thing. So let me just ask about then weather observers, because there's a lot of weather observers stationed all around Antarctica. What are the weather observers observing that the automatic weather stations can't?
Okay. The big thing I think the observers get that the automatic weather stations don't is information about clouds and about precipitation. And those are two quantities that are difficult to measure remotely, and particularly measure remotely and without a lot of power available. So that's an important thing. So we have something like 70 weather stations from the group at Wisconsin around the Antarctic continent, but they don't tell us anything about precipitation. They don't tell us anything about cloud cover. And those are two important properties of the atmosphere.
But one thing it does, it's got this laser or whatever that points up to see how low the clouds are, right? Or the LTER ones had something like that.
Yes, the Wisconsin weather stations don't.
Okay. But even that, it's just one point.
Right. Although a lot of the observations, even in the U.S., have switched from human observers to automated weather stations, and they do have automated precipitation measurement and automated cloud cover measurements, and they have the vertical pointing lasers, the ceilometer that measures the height to cloud base. And
so potentially you don't need human eyes out there.
No, but things always go wrong. You get problems. Your rain gauge has become blocked with blowing snow, or all kinds of things can happen that a human observer going out day in and day out and making measurements would see, and an unmanned, untended weather station sitting out there. You have no idea, and you might get clues, in looking at the data that something has gone wrong. But I think there's a real value to human observers. With that said, human observers introduce, you sort of get a bias in that every person will look at some state of the atmosphere, and it's a little bit different to them. They might report a slightly different cloud cover, estimate a slightly different cloud base, and so